Have you ever struggled with checking if a big number is divisible by another number? Well, what if I tell you there is a secret method to check divisibility without doing any division? Sounds impossible, right? Stick with me till the end because today we are mastering all 15 divisibility rules. And trust me, after this video, you will be faster than a calculator. Hey everyone, welcome back to Godwills Talent Hub. This is Satish, and today we are learning something that will literally blow our minds. Before we start, let me challenge you. Pause this video right now and try to tell me, is 2451 divisible by 3? Can you do it in your head without a calculator? By the end of this video, you will be able to answer this in just 3 seconds. Excited? Let's go. But first, if you're new to the channel, subscribe to Godwills Talent Hub and hit that bell icon so you will never miss amazing content like this. Let's start with our super simple divisibility rule, that is 1. Here is the rule. Every single number in the universe is divisible by 1. Yes, all the numbers. 5 divided by 1 is 5. 100 divided by 1 is 100. 999 divided by 1 is 999. All these numbers are exactly divisible without leaving any remainder. Easy peasy, right? That's a warm-up. Now let's get into the real magic. Divisibility by 2. This one is a classic. The rule is super simple. Just look at the last digit of the number. If it is 0, 2, 4, 6 or 8, it is divisible by 2. Let me give you few examples. Take 14. The last digit is 4. That's even. So yes, it is divisible by 2. How about 58? Last digit is 8. Even again. So yes, even this number is divisible by 2. But wait, what about 15? Last digit is 5, which is an odd number. So no, it is not divisible by 2. See how quick that was? No calculator, no long division, just a quick glance at the last digit. This is the power of divisibility rules. Now, here is where it gets really interesting. Divisibility by 3. Listen carefully. Add all the digits of the number together. If the sum is divisible by 3, then the entire number is divisible by 3. Let's try it with 123. Digits are 1, 2 and 3. Add them up. 1 plus 2 plus 3. The sum is 6. Is 6 divisible by 3? Yes. 6 when divided by 3 we get 2 as the quotient. So 123 is divisible by 3. One more example, and this is a big number, 2451. Add the digits, 2 plus 4 plus 5 plus 1. All these digits sum up to 12. Is 12 divisible by 3? Yes, of course. 12 is divided by 3. We get 4 as the quotient and the remainder is 0. Therefore, 2451 is divisible by 3. Remember the challenge I gave you at the beginning? This is how you solve it. Mind blown, right? Perfect. Moving on to the divisibility by 4. Here is the trick. Look at the last 2 digits of the number. If those last 2 digits form a number that is divisible by 4, then the whole number is divisible by 4. Take 516 as an example. The last 2 digits are 16. As 16 is divisible by 4, 516 is also divisible by 4. Another example, 2324, where the last 2 digits are 24 and it is perfectly divisible by 4. Therefore, the entire number 2324 is divisible by 4. And now look at 522. The last 2 digits are 22. When you divide 22 by 5, you get the quotient as 5. However, there is a remainder, which is 2. That means 22 is not getting divided perfectly with the help of 4. Therefore, 522 is not divisible by 4. Quick and powerful, right? Perfect. Divisibility by 5. This is probably the easiest rule you will ever learn. If the last digit is 0 or 5, it is divisible by 5. That's it. Let's take a couple of examples. 25, where the last digit is 5. Therefore, this number is divisible by 5. 100, the last digit is 0. Hence, the number is divisible by 5. Now look at the number 3455. It ends in 5. Yes, even this number is divisible by 5. But 23 ends in 3. Hence, this number is not divisible by 5. You probably already knew this one from your multiplication tables, right? But it's still super useful. Now, here is an interesting one, divisibility by 6. For this, you need to pass 2 tests. The number must be divisible by both 2 and 3. Let's check 42. Test 1. It is divisible by 2 because the last digit is 2. And when you add those 2 digits, 4 plus 2, it becomes 6. That means it is also divisible by 3. As it passed both the tests, 42 is divisible by 6. See, we are combining rules we already learned. It's like building blocks. Alright, now we are getting into the tricky ones. Divisibility by 7. Pay a close attention. Here is the process. Take off the last digit from the given number. Double that digit and subtract it from what is left. If the result is divisible by 7, the original number is also divisible by 7. I know it sounds confusing, so let me show you with an example. 203. Here, the last digit is 3. And what's remaining? It is 20. So double the last digit. 3 times 2 is 6. Subtract the 6 from 20. It becomes 14. Is 14 divisible by 7? Yes, absolutely. Right? Therefore, 203 is also divisible by 7. This one takes practice, but once you get it, you will feel like a math genius. Let's get into the next divisibility rule, that is divisibility by 8, which is as similar as 4, but instead of 2 digits, we look at 3. Look at the last 3 digits. If they form a number which is divisible by 8, then the entire number is divisible by 8. For example, 5120. Here, the last 3 digits are 120. Is 120 divisible by 8? Let's see. 120 when divided by 8, we get 15. That means, yes, there is no remainder left. Therefore, 5120 is divisible by 8. And look at the other number. It is 78,248. Here the last 3 digits are 248. And when you divide 248 with 8, we get a perfect 31 as the quotient and the remainder is 0. That means 78,248 is also divisible by 8. Now let's get into the next rule, that is divisibility by 9. This is almost identical to the rule for 3. Add all the digits together. If the sum is divisible by 9, then the number is divisible by 9. Example, 108. When you add the digits 1 plus 0 plus 8, we get 9. Is 9 divisible by 9? Of course, why not? When 9 divided by 9, we get 1. And there is no remainder. So, 108 is also divisible by 9. Another example, 2916. Add all the digits, 2 plus 9 plus 1 plus 6. Altogether it becomes 18. Is 18 divisible by 9? Yes. 18 when divided by 9, we get the quotient 2 and the remainder is 0. Therefore, 2916 is divisible by 9. See the pattern? It's just like rule 3, but with 9. Perfect? Alright, now let's get into another super simple rule, which is divisibility by 10. And this is the easiest rule in the entire video. For divisibility by 10, the last digit must be 0. That's it. Nothing else. 10, yes, it has 0. 50, yes, it has 0. 1000, yes, it has 0. But 25, no, because it doesn't end in 0. Too easy, right? Moving on. Now, here is a fascinating one. Divisibility by 11. This uses something called the alternating sum method. Here is how it works. Add all digits at odd positions, that is first, third, fifth, seventh, and so on. Add all the digits at even positions, second, fourth, sixth, eighth, and so on. Subtract the two sums. Try to find the difference of those two sums. If the result is 0 or divisible by 11, the entire number is divisible by 11. Let's try 1331, 1331. Here, the first and the third positions are 1 and 3, and the second and fourth positions are 3 and 1. So when you add the odd position digits, that is 1 plus 3, 4, and the even positions digits, that is 3 and 1, 3 plus 1, 4, and you subtract or you find the difference of those two sums, that is 4 minus 4, it becomes 0. As the result is 0, 1331 is divisible by 11. This one is like a math puzzle, isn't it? Super cool. Divisibility by 12, another combo rule. The number must be divisible by both 3 and 4. Let's check 132. Divisibility by 3. The first test. Add all the digits. 1 plus 3 plus 2, 6. As you know, 6 is divisible by 3. So it has passed the test 1. Now let's look into the test 2. Divisible by 4. Last two digits in 132 are 32. And 32 is exactly divisible by 4. Therefore, as it passed both the tests, 132 is divisible by 12. We're just combining what we already know. Smart, right? Perfect. Now, divisibility by 13 is much more interesting. Here is the method. Remove the last digit, multiply it by 4, add it to what's remaining. If the result is divisible by 13, the original number is also divisible by 13. Let's try with an example, 221. Here, the last digit is 1 and the remaining is 22. Multiply 1 with a 4, you get 4. Add this 4 to the remaining 22. So it becomes 26. Is 26 divisible by 13? Yes, of course. 26 divided by 13 is 2 and the remainder is 0. Therefore, the number 221 is divisible by 13. Notice how this is similar to rule 7. But we add instead of subtract. In 7, we subtract. In 13, we add. Alright, almost done. Just 2 more. Divisibility by 14 must be divisible by both 2 and 7. Let's quickly check 98. It is divisible by 2 because the last digit is 8. And divisibility rule of 7. 8, double it. That is 8 into 2, 16. 9 minus 16 is minus 7. And minus 7 is perfectly divisible by 7. That is minus 1. Leaving a remainder 0. Therefore, 98 is divisible by 14. And finally, divisibility by 15 must be divisible by both 3 and 5. Let's check with an example, 75. 7 plus 5, 12, and 12 is divisible by 3. Therefore, test 1 is passed. Now let us look into the test 2, where it should be divisible by 5. When you look at the last digit of 75, it is 5 and it is divisible by 5. Therefore, 75 is divisible by 15. And that's it. We have covered all 15 rules. Wow! Look at what we just accomplished. Let me quickly recap all 15 rules for you. Rule number 1. All numbers are divisible by 1. Rule number 2. Last digit should be even. Rule number 3. Sum of the digits should be divisible by 3. Rule number 4. Last two digits divisible by 4. Rule number 5. Ends in 0 or 5. Rule number 6. Should be divisible by 2 and 3. Rule number 7. Double the last digit and subtract. Rule number 8. Last three digits should be divisible by 8. And rule number 9. Sum of all the digits should be divisible by 9. Rule number 10. It ends in 0. Rule number 11. Alternating sum. Rule number 12. Divisible by 3 and 4. Rule number 13. Multiply last by 4 and add. And rule number 14. Divisible by 2 and 7. The last but not the least, rule number 15 should be divisible by 3 and 5. These rules are incredibly powerful. You can use them in exams, competitive tests, or just to impress your friends and teachers. Now, I want you to practice. I'm going to give you 3 numbers and I want you to pause the video and figure out. Is 144 divisible by 12? Is 847 divisible by 7? Is 5895 divisible by 50? Comment your answers below. Let's see who got all 3 correct. And if you're struck, watch the video again. Practice makes perfect. Let me tell you why these rules are so important. They save tons of time in competitive exams or any math Olympiad. They make mental math incredibly fast. They help you understand number patterns better. They boost your confidence in mathematics. They are impressive. Seriously, try this at school and watch everyone's reaction. These aren't just tricks. They are mathematical shortcuts that have been used for centuries. Alright everyone, we have reached at the end of this amazing journey through the divisibility rules. But before you go, I need 3 things from you. If you learned something new today and found this video helpful, smash that like button. It really helps the YouTube algorithm show this video to more students who need it. Share this video with your friends, classmates and study groups. Trust me, they will thank you when they ace their next math test using these incredible tricks. And number 3, subscribe to Godwills Talent Hub if you haven't already and ring that bell icon. We create amazing educational content just like this and you don't want to miss out. We have got videos on fractions, prime numbers, percentages and so much more soon. You are like, share and subscribe help us reach millions of students and create more awesome content for you. Thank you so much for watching and sticking with me through all the 15 rules. You are now officially a divisibility master. I'm Satish from Godwills Talent Hub and remember, mathematics isn't about memorization. It's about understanding patterns and using smart techniques. Keep practicing these rules. Drop your practice answers in the comments and I'll see you in the next video where we will explore even more amazing math concepts. Until then, keep learning, keep growing and keep being awesome